Yeah, hello everyone. My name is Stefan Hagedorn and I'm going to present our paper, Putting Pandas in a Box, which is about moving data frame operations from Python to the database system. The motivation for this work is that companies and researchers have large amounts of data from their forms, from their product information, from their sales information, from the reviews of their products, and from the customer information that they collected, but also from other sources like news or events. So, and for decades, they have been told to store this kind of information in database systems. So they bought new servers, they rent large cloud machines, and they put much effort into a data schema across these servers. And now the data analysts have to analyze this data, for example, to find important entries, to do complex calculations for their data science task, or to run some prediction models on this data. And they choose their favorite languages and frameworks, for example, Python and Pandas, but this is not very efficient and they have to wait forever for these pipelines to complete. So you might say this is not really this bad situation. So we did some experiments. So we loaded a 1 GB file with Pandas and some other systems. And you can see with Pandas, you already have to wait 150 seconds for a simple processing pipeline to finish, and provide 5 GB of RAM already for 1 GB input data. Okay, maybe that's something that your workstation can handle. So if you increase the data set size to 2 GB already, you have to wait 300 seconds for this to complete and provide already 8 GB of RAM. Okay, that's something that your workstation may have nowadays. But if you increase the data set size more, up to 5 GB, for example, then you have to wait several minutes for Pandas to complete, and you have to provide already more than 20 GB of RAM. And this is something that not every workstation can handle. Okay, and this is a challenge that we want to address with our Grizzly project. So Grizzly is a framework to translate data frame operations to SQL. And in our data frame implementation, we follow this lazy evaluation approach. That means we have, let's say, hollow data frames, which do not contain any data, but only collect the operations that are performed on them. And then these operations are translated to a SQL query. So this is, we do not want to download the data into the client, but instead we want to ship the query into the database server where the data is already stored. And for execution, we rely on the database management systems features, so standard SQL, of course, but also for executing user-defined functions or accessing external data. The general architecture of Grizzly is that we construct an operator tree from the operations on a data frame, but we leave the actual control flow of the Python script in the local Python interpreter. So we can see here, we have this example script and we generate this operator tree. And then using this mapping shown in this table, we construct a SQL expression for every operator. And we wrap it around the SQL expression of its previous operator. So this is the loading here of the table. And then the projection uses this loading here in a nested query and so on. And we rely on the database system to optimize this query and flatten it currently. So it may be the case that not every data set was already loaded into the database system or should be loaded at all because it's not needed there in a permanent manner. And we make use of features that many systems provide. For example, in Postgres, this is named foreign data wrappers. In Vector, it's called the external tables, or MongoDB has this concept of creating tables from a Python loader function. And every time such external file is loaded, we create a vendor-specific code in a pre-query block that is added to the actual SQL query. So loading a file can be done using this function in Grizzly, and this will be translated into Vector, for example, into this external table expression here with all these parameters given in this function here. And after that, we can use this external table like any other normal database table. And this vendor-specific code is generated using templates that we provide in a configuration file so that users can simply add their own templates for the systems that they use. And in future work, we will look into how we can also process data locally in the client if it's really necessary. And there we will make use of some embedded database system like MongoDB, DuckDB, or the Apache Arrow project. So in our experiments here, we analyzed the join performance of a database table with the external file or data from an external file, and we varied the number of rows in this external file up to 3 million rows. And you can see that Pandas scales really bad, even for this very small external file. And for the 3 million rows case here on the right-hand side, you already have to wait 380 seconds for this join to complete. And the main reason why Pandas is so slow is that it has to download the data from the table, from the database server into the local client machine. Whereas you can see in Grizzly, all these experiments finished within less than 5 seconds. Okay, now not every operation that needs to be executed may be available as a SQL expression. So users will have to write their own functions to apply on the data sets. And in Grizzly, this can be done using this map operator here, where you provide a function that you've written yourself. And in Grizzly, we will ship this function into the database system and create it there as a native function, let's say. And this is a Postgres example here, again, taken from the configuration file, the templates stored there, and then it can be applied in the projection like it was a traditional Python function, SQL function here. There is a gap, however, because usually in Python you don't have types, whereas in SQL you are required to add types to your parameters, for example. And therefore we make use of these type hints that were introduced in Python 3.5. Okay, currently this Python language support is in beta only in most systems. So for example, in Postgres, you need to be a super user to be able to execute or create Python functions. But we believe that in future, this important feature will be addressed by the database companies and will be brought into a stable form. There are some differences how these systems handle the Python support. For example, in Postgres, you have one Python interpreter per worker, which is restarted for every query. Whereas in Vector, for example, you have one global Python interpreter that runs as long as the system is running, and every worker will access the same interpreter. So this allows you to cache some values, but it also violates the isolation. So there's a trade-off here. But that's something that we consider in our templates, and so we can make use of this caching functionality. So very interesting now is how users can apply machine learning models onto the data inside the database system. So we provide this apply model function here, where users only need to specify a path to a model and 2 conversion functions. One function is to convert the input, so the data from the database system, to something that the model understands. And the other function is to convert the output of the model to something that the database system understands. We support Python, PyTorch, TensorFlow, and Onyx functions. And yeah, as you can see, almost no user code is required. And these conversion functions are often given on the websites where you can download the model. And we make use of the UDF functionality to convert this into a SQL function, which is then used in a query. And our experiments showed that Pandas really, again, scales very bad, even for small input tuples where we classified movie reviews using the Roberta model. And you can see Grizzly is much faster than Pandas, but also faster than Modin. regardless if it can cache its model or not. So in summary, let's say that Grizzly provides a data frame implementation that translates the operations into SQL expressions. It is possible to access external data and process this data inside the database system. You can run UDFs that you've written in Python, and you can apply machine learning models using PyTorch, TensorFlow, or Onyx inside the database system. So instead of downloading the data to the client, now the client only has to send the query to the database system using Grizzly. Thank you.